And in this video, let's talk a little bit more about the potential energy. So we mentioned earlier that you can, roughly speaking, think of an object's potential energy as being its potential to gain motion later on. One thing you'll notice right away, and this is one of the things that people get wrong the most about potential energy when they're first getting started out in this subject, that this could be due to any number of a wide variety of different effects. So when you think about potential energy, you don't want to think about one specific cause of potential energy or one specific source of potential energy or one specific formula for potential energy. So each different effect which can cause a potential energy has its own formula associated with it. There isn't one universal formula for potential energy. So again, a lot of times students are searching for what's the formula I plug into for this. I want to say right off the top, there isn't just a formula you plug into for potential energy. This is the exact same statement like in Newtonian physics. Like if you ask me, what's the formula for force? What do you mean? There isn't one formula universally for a force. It depends what force you're talking about. Gravity has a force, springs have a different force, friction has a force. You will learn about all these different formulas for different forces. Likewise, each force is going to have its own potential energy associated with it, and each one of these potential energies is going to be calculated a different way. So get yourself out of the idea right now of having a formula for potential energy. That's going to be problem specific. So what you plug into for potential energy in a problem depends on the problem. If the problem is about something falling under the influence of gravity, you'll use the formula for gravitational potential energy. If a problem is about an object that's on a spring that's snapping back to its rest length, you'll use the formula for spring potential energy, and so on. Or you might have a problem where you have multiple different kinds of potential energy, in which case you just add them up. Let me actually make a bullet point for that too. If you have multiple different sources of potential energy in the same problem, you'll calculate each one according to its own formula and add them all up to get the total potential energy. We will, over the course of the next number of lectures, talk about some examples of different potential energies and what their formulas are. But at this moment, don't worry too much about having a formula for it. That will be problem specific. Oh, there's a few other things I should say about potential energy, though. We'll get into this in a little bit more detail later on. But when you compare it to kinetic energy, zero potential energy doesn't have a specific universal meaning. We'll explain why a little bit later on. And unlike kinetic energy, potential energy can be positive or negative. It still has no direction associated with it, but it does have a sign associated with it, for reasons that maybe we'll get into a little bit later on once we understand it a little bit better. But just so you know, it can be negative in this case.